Hi, we're here in the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas. And I'm joined here with Mary Cerimele, who is the project manager with the Johnson Space Center Vacuum Chamber. Thanks for joining us. And we're going to turn it over to the students there at the Distance Learning Network event. Thanks so much for joining us.
Thank you.
All right, now if we could have our first student ask their first question, that would be great. Remember, nice and loud.
How do you make sure that the model used in the testing chamber does not get destroyed?
That's a really great question. It will be hard to destroy it by something like fire because there's not going to be any air in our test chamber. And we did very careful design to make sure nothing would fall on it. And then in between now and when the actual telescope gets to the chamber, we're going to be doing a series of practice tests to make sure that all of our operations are safe so that when it gets in there, we are the last people that want to damage a telescope that costs billions of dollars.
Great, thank you. Do you want us to go on to question number 2?
Yes, please.
Okay, great, thanks.
What material do you put on the Webb telescope that makes sure it does not burn up?
Space materials are kind of different from Earth materials because it's difficult to keep things the right temperature in space, and some things when they're exposed to space tend to have things evaporate off of them. So you have to really carefully pick materials for space. So that's a good question. Luckily, where the James Webb Telescope is going to be eventually is in a spot that's so cold that we won't have to worry about it burning up. The only time when it will be warm when it's on the launch vehicle, and when it's on the launch vehicle, it'll be enclosed by a metal cone that'll protect it during the launch. But then after it gets up there, it's more a matter of keeping it warm rather than having to make sure we keep it cold until it gets to where it's going. And when it gets where it's going, we want things there to be so cold that they've gone to a lot of effort to try to keep the James Webb Telescope instruments very, very cold, minus 400 degrees Fahrenheit.
Thank you.
You're welcome.
What are the limits to the Webb and its telescope? How far can it see?
You're going to have to repeat that one. Somebody was laughing behind me and I couldn't hear you.
What are the limits to the Webb and its telescope? How far can it see?
That's another really good question. The Webb telescope is going to be able to see between 10 and 100 times farther than the Hubble telescope. When we say how far can it see, it's more of how dim of a light it can see, because the more dim a light it can see, that's farther back toward the start of the Big Bang than we've ever been able to see before. So it's kind of like a time machine in a way, because by the time the light, the infrared light that it's collecting, gets to the telescope, that light will have originated over 13.5 billion years ago from its source, and it just took that long to get to the telescope to read it. So by the time the telescope gets that light to read it, it's 13.5 billion years old. And because of that, we'll be able to see the very first galaxy formations. So far, the Hubble's been able to see galaxies, early galaxies after they formed, but James Webb Telescope wants to see the galaxies as they're forming and before they're forming, and that will be a whole new range of science that we've never been able to do before. We're going to get very close back to as close as we can back to the Big Bang. That's a good question too.
Thank you. Will the Webb telescope eventually fall down to Earth and be replaced like the Hubble?
Yeah, it's kind of sad that someday Hubble will come back to Earth, isn't it? Hubble's actually orbiting about 350 miles above Earth. And because it's orbiting Earth, eventually when the fuel runs out and gravitational forces have their effect, it will eventually come back. But the James Webb Telescope isn't going to be orbiting Earth. It's going to be 1,000,000 miles away from Earth in just a point of space, and it's not so it won't be orbiting us. It won't. It's going to be in a point in space where the effects of the gravity on Earth and the effects of gravity on the sun kind of cancel each other out, so that neither one's pulling on the other. And since it's 1,000,000 miles away and it's not orbiting Earth, there's nothing to pull it into Earth so that it will burn up. Eventually, when it runs out of fuel, it's and it isn't able to stay in the right spot anymore, it will eventually drift off into the solar system and beyond. But it won't be coming back to Earth.
Thank you.
You're welcome.
How many hours does it take to test a part in the chamber?
I really like this question because you asked me that question in hours, and I have to give you the answer in days. It's going to take us 90 days to do the test in our chamber once we get to the final test. And the first 3 weeks of that test are going to be more boring than watching paint dry, because the only thing it's going to be doing is trying to get it as cold as it's going to be when it eventually gets to its spot out in space. And then the next few weeks will be spent taking data to make sure all of its instruments work and the mirrors work and all of that. And then the last couple weeks are going to be really boring too, because then we just have to warm the thing back up so that we can bring it back out of the chamber. But yes, it will end up being measured in weeks.
How cold does it get in the chamber exactly?
We're actually really proud of this. The chamber itself will get to minus 440 degrees right now. We may be able to get a couple of degrees colder than that if we put a little more effort into it. But the James Webb Telescope, since it's supposed to work at minus 400, the test chamber has to be colder than that so that it can operate like it's going to be in space. And so we can get down, we'll have the coldest place on Earth in Texas in August when we end up testing this.
Thank you.
Thank you.
Could the vacuum chamber...
There you go.
Could the vacuum chamber hypothetically be used to give astronauts a more realistic experience of space simulation than the training pool?
Yes, as a matter of fact. In fact, we have a few vacuum chambers at Johnson Space Center that we do use to give the astronauts a sense of how equipment will work in a vacuum and how their spacesuits will work in a vacuum. In fact, Chamber A, the one that's going to be testing the James Webb Telescope, was one of the first vacuum chambers we used, and the Apollo astronauts spent 2 weeks inside of their space capsule in that chamber checking out how the capsule worked. So yes, it has been used for that. It will probably be used for that again after the James Webb. But in the meanwhile, we have other somewhat smaller, more human-sized chambers that we used, and we can put people in there so that they can get an experience of vacuum. However, I probably should add to that once we put a vacuum in there, the gravity stays. So that's one of the things that the pool does for us, is the pool kind of simulates what it's like to live without gravity, and the vacuum chamber simulates what it's like to live without air. So we really need to have both of those, because we can't do one at the same time as the other.
Thank you.
What is the most important test that you run on the telescope?
I heard what is the most important test, and then I didn't hear the rest of it.
That you run on the telescope.
The most important test we're going to be running on the telescope here on Earth in the chamber is we're going to be operating all of its instruments to make sure that they're able to see we're going to put kind of a test universe out there for it to look to see if it's picking up the lights in the right wavelength, if it's able to be pointed in the right direction, and then to make sure that the mirrors all stay aligned with each other. The thing has 18 mirrors. It's so big that it can't launch without being folded up. So when it launches, it folds up like a transformer, and it unfolds while it's heading on its way out to the moon. Past the moon, I should say. And so when it unfolds, all these mirror pieces, the 18 mirror segments, have to line up with each other, and they all have to work together. So that's one of the things we'll be testing there, is will all these work together when they get as cold as they're supposed to get out there in its point in space.
Thank you.
How do you test the equipment in the chamber? And what kind of test do you have to run?
How do we test the James Webb telescope in the chamber?
Yes.
Well, we're going to put it into the chamber while the chamber has air in it, of course. And then the first thing we're going to do is we're going to remove all of the air from the chamber and then start to make it very, very cold. From there, we'll start turning on the infrared sensors, which the James Webb telescope has 4 different kinds of infrared sensors. And we're going to turn on a source as if it was looking for a very faint galaxy 13 billion years ago and see if those sensors pick up on that source. Did that answer your question?
Okay, and then, yes, and then how many cubic feet of space does the chamber hold?
Oh, the chamber holds 400,000 cubic feet. It's big. You can fit several buses inside this chamber. It's 120 feet tall by 65 feet in diameter. And the door on it is 40 feet in diameter. It's a big circular door, sort of like a giant hobbit hole. And that's how we get things in and out of the chamber. But it's really huge.
Thank you.
How did you get to be in the position you're in, and what is your degree?
Oh, I have a couple degrees. One is aerospace engineering, bachelor's in aerospace engineering, and then I got a master's in mechanical engineering as well. And how I got in the position I am in, wow, that's a really hard question, really good question. I found something I really liked to do here at NASA. I really liked working with the test chambers and vacuum and the astronauts and their spacesuits, and just started working my way up through levels of responsibility once I got here. And so eventually we came upon this huge project where we needed to get a chamber ready for this next great telescope adventure. And I'd already had a lot of 15 years of experience in working with chambers, so I was ready to volunteer to take that on.
Why are the mirrors on the telescope hexagons?
You know, I saw this question because I saw some of the questions ahead of time, and I saw this question and I said, wow, that one kind of stumped me. So I went and looked up the answer for it. And essentially it's as simple as the fact that since the telescope, since the primary mirror is made up of 18 segments and it has to be so big that it has to be folded, that meant that they couldn't create one giant single piece mirror like the Hubble was. They had to break it up into segments. The easiest way to break it up into segments and still have all the pieces able to touch each other to create one solid mirror surface is hexagon shapes. That's the easiest packaging, where all the edges will line up with each other. All the way, I'm sorry, I clicked off, where all the edges will line up with each other without gaps in between them.
And how long, or how many years did it take you to get to the point you're at right now?
The James Webb Telescope, they started talking about the telescope itself around the year 2000. It got named the James Webb Telescope in 2002, and they've really started working on it in earnest since about 2002, 2003. We at JSC got involved in 2005 when they came and said, you know, we're going to need to test this thing somewhere, and it's so big, I think yours is the only place we can really do this and still have it be cold enough. And so we started in 2005 to rearrange the whole chamber so that it could get cold enough for the James Webb Telescope. But we've really, most of the work has been in the last 3 years, last 3 and 4 years.
Thank you.
What was the most dangerous thing that has ever come close to the Earth, and what can the James Webb Space Telescope do to prevent that or prepare us for that?
Well, the James Webb Telescope will be able, it's not just going to be able to look for galaxies that are very distant, but it's also going to be able to look at our planets in our solar system and look at asteroids that are floating around. And I'd say the most dangerous thing that's come to Earth has probably been a couple of large asteroids. The most recent one, well, I mean, the one tens of millions of years ago that they theorize killed off the dinosaurs. But 100 years ago, there was one that was 10 times the size of the Titanic that landed in a remote area of Russia and pretty much flattened an area the size of Dallas-Fort Worth. Luckily, there was just 80 million trees in the way, but those 80 million trees suffered. So a giant asteroid, I'd say, is probably the most dangerous thing that has come to Earth in the past. And we will be able to track asteroid paths as they approach Earth.
We have one more question for you.
Okay.
11.
How long does it take to get something approved before you test it?
Oh, I didn't catch all of that. Can you say it again a little louder?
A little louder, just louder.
How long does it take to get something approved?
Oh, how long does it take to get something approved? Wow, that's an excellent and tough question. Generally, a new idea will take a couple of years to get approved because all of our new projects have to be approved through Congress. And if it involves building something, we need about a 3-year advance warning before we are able to start building something. So like they started talking about the James Webb Telescope in around the year 2000. It will launch in 2018. So that kind of gives you an idea of the time between thinking of the idea and actually making it happen. So a long time. So you got to think about what it is you want to have happen now, because 20 years from now, you might be making it happen. So you can write your congressman now for what you want to see happen.
Thank you.
Okay, we have one last question for you.
Okay.
How do you get the chamber to get so cold?
Oh gosh, the chamber has a series of walls inside of it. It's got its inside layer of walls actually has tubes running through it that carry liquid nitrogen. And liquid nitrogen makes those walls about minus 300 degrees Fahrenheit. But that wasn't cold enough for James Webb, the telescope. So we put in another layer of walls inside of that. And that one is going to, it has tubes running through it too. And those walls are going to carry gaseous helium that we've refrigerated the heck out of. And we've gotten the helium so cold that it's only 10 degrees above absolute zero. And absolute zero is something that's a theoretical temperature that nothing achieved. So this is 10 or 11 degrees above a theoretical lowest temperature in the universe. And so once we get the walls that cold, the whole chamber inside will get that cold. But interestingly enough, the wall, if you leaned up against the walls on the outside of the chamber, which are about 2 inches thick, it would just be a nice 65 degrees. But the inside of the chamber will be minus 440.
Thank you. Thank you. Thank you so much for answering all their questions. I know through this they've learned a lot. I really appreciate your time today.
I think that they asked really terrific questions. Thank you for having such great questions.
Thank you.